4.1 is called graphs of the sine and cosine function, and it's the most important and essential lesson of chapter 4. Before we start talking about the graphs, we need to learn the term called periodic functions. Many things in life repeat with a predictable pattern, such as weather, tides, and hours of daylight. This periodic graph represents a normal heartbeat. So when we try to understand what this graph is saying, we see a full figure of this shape, and then whenever it ends, it just repeats itself again. It stops, and there is nothing like brand new shape coming when the cycle is over. It's just repeating itself. And this is called a periodic graph because periodically the graph, it repeats itself. So a periodic function in math, a function such that f of x is equal to f of x plus np for every real number x in the domain of f, every integer n, some positive real number p. So the long story short is, if the graph is repeating itself, this is called a periodic function. And the least possible positive value of the p is called the period. So when we figure out how often it repeats itself, this is called the period. The circumference of the unit circle is 2 pi. So the least possible value of p for which the sine and cosine function repeats is 2 pi. This information is important here. The cosine function and sine function for the parent graph, their period is going to be 2 pi. So every 2 pi, the cosine function and the sine function, they're going to repeat itself. 2 pi is the period for sine and cosine graph. Now we're going to try to understand how to graph f of x of sine of x using our trigonometric knowledge. So when we look at f of x is equal to sine of x, this is the x domain, and f of x represent the y. So for the sine and cosine function, domain is from negative infinity to positive infinity, and the sine values cannot be higher than positive 1, and they cannot be lower than negative 1. These are the facts that we studied in previous chapters. If we create a table and choose some random values for x and evaluate the corresponding y values, we can actually obtain the graph. The very first angle we're going to plug in is 0, and sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is √2 over 2, and so on. We know these values from the unit circle. Now, if we plot these ordered pairs, x is 0, y is 0, so it creates this point. X is pi over 6, y is 1/2, so pi over 6 is somewhere here, and then its y value is 1/2. If you just plot all these points, you're going to obtain the full sketch of the sine graph. So sine graph, it starts from here, and it's one full cycle fits in 2 pi period, and it goes as high as positive 1 and as low as negative 1, and then this total distance is 2 units, but if you cut it in half, you can find its amplitude as 1. And then if you graph the same thing using a graphing calculator, you will obtain this green figure. When somebody asks me to graph sine of x on my own, I don't generate this many values for the function to obtain some critical values. The x values I need is actually just 0, pi over 2, pi, 3 pi over 2, and 2 pi. If I can just get the corresponding y values for these 5 angles, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. And just showing these 5 points will be enough for me to sketch the curve on my own. So 0, 0 is located here. Pi over 2 goes to the positive 1, goes here. Pi goes to a 0, and 3 pi over 2 goes to negative 1, and 2 pi goes to a 0. And when I connect these 5 dots, I can get the full cycle of the sine graph. And then for the rest of the x-axis, I can just copy the same sketch as many times as I need. And then this is how I can graph the sine of x without a calculator. Now, for the sine of x, if we analyze, what do we notice? We have to know that the graph is continuous. So there is two things, discrete and continuous. Continuous means when the graph starts, you can trace it without lifting your pencil. So there's no hole, there's no gap. So the graph is continuous over its entire domain. And the domain for sine graph is negative infinity to positive infinity, which means you can repeat this graph as long as you want to repeat it. So it will never stop. And then that's what it means. The x-intercepts are in the form of n pi, where n is an integer. So we also have to know that period is 2 pi. So one full cycle is going to take a space of 2 pi. So when the graph starts from here, rises all the way here, decreases again, and then starts rising again, and finally stops at 0, this whole thing fits in 2 pi. That's the period of the sine graph. And the graph is symmetric with respect to the origin. So the function is odd function. This is a very important information. Sine is an odd function, which means that if sine of pi over 6, sine of 30, is equal to a 1/2, or odd function means if somebody asks me sine of negative pi over 6, so that when the angle changes from positive value to negative value, I'm going to still get the same answer, but it will take a negative in front of it. That's the definition of the odd function. Sine of pi over 6 is positive 1/2, but sine of negative pi over 6 is negative 1/2. So this will never be a different fraction. It will be the exact same fraction as the positive version, but the sign will change it to an opposite version. That's what odd function means. And sine is an odd function. After saying enough things about sine function, let's take a look at the cosine function. Just like sine function, it will be very important that we know how to derive the values for cosine of x. You can use as many x values as you like, and here the book used a lot of x values to calculate the corresponding cosine of x values, which are very useful. Then they started plotting the points and they got the graph for cosine of x. Just like the sine of x, again, I do believe that I don't need this many numbers to understand the sketch of the cosine of graph on my own. I'm going to use the same 5 angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to evaluate the cosine values for these angles only. Cosine of 0 is 1, cosine of 90 is 0, cosine of pi is negative 1, cosine of 3 pi over 2 is 0, cosine of 2 pi is, we're back to positive 1. So when I plot these 5 points on the coordinate plane, 0 goes to positive 1, pi over 2 goes to the 0, pi goes to negative 1, 3 pi over 2 matches with a 0, and 2 pi matches with the 1. And then when I connect these 5 dots, I can understand the full cycle of the cosine graph. So cosine graph is this kind of V-looking shape. And again, it starts from 0, but it ends at 2 pi. So even the cosine of x has the same period as the sine of x. One full period fits into 2 pi distance. And then the cosine graph also goes as high as positive 1 and as low as negative 1. Therefore, its range is same as the sine of x, and its domain is same as the sine of x. We can also talk about that cosine of x is continuous graph, just like the sine of x. So when we started sketching the graph, we didn't have to create a hole, or we didn't have to lift our pencil. One full curve was obtained without lifting the pencil, and it's a continuous graph on its entire domain. Its period is 2 pi, so in order to fit the full sketch for the cosine of x, we need the distance of 2 pi. And this time, the graph is symmetric with respect to y-axis. So this is the y-axis. These two parts will match to each other. So cosine is an even function. This is very important. Cosine is an even function. That means even the angle changes to a negative version, you will still get the same output as the positive x. I would like to show an example. Cosine of pi over 6, so cosine of 30 is equal to root 3 over 2. But if the angle changes from pi over 6 to negative pi over 6, because cosine is an even function, he doesn't care about angle changes to a negative version. It still gives me the same output, root 3 over 2. This is the special thing about cosine. Cosine is an even function. So when you change your input to a negative version of your input, your output stays the same because it's symmetric with respect to the y-axis. So not always we're going to have to graph the parent functions like sine of x, cosine of x. What happens if we need to graph y equals 2 sine of x? So to understand what is going to change from the graph of y equals sine of x to 2 sine of x, let's create the chart again for sine of x. We know that for the parent graph sine of x, the most basic version of the sine graph sine of x, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. And these are the outputs we're going to get. Now, this 2 here in the new question, all of your y values will be multiplied by 2. So this is called a vertical stretch. All these y values now, I have to multiply them by 2 because that's what 2 times sine of x means. If this is sine of x, 2 times sine of x is still a 0. This is sine of x is 1, so 2 times sine of x is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times 0 is 0. So the y values, we had to multiply them all by 2 because the graph changed from sine of x to 2 sine of x. If we plot our new 5 points for the 2 sine of x, 0 still went to the same point, but pi over 2 didn't stop at 1. Pi over 2 became a 2 now, the corresponding y value. For pi, the y stays at 0. For 3 pi over 2, the y became negative 2 for 2 sine of x. And then for 2 pi, it stays at 0. And when we connected these 5 values, we noticed that 2 sine of x is 2 times taller than 1 sine of x graph. So all the y values, we had to multiply them by 2. So the new graph, 2 sine of x, it is 2 times taller than the original graph. We have to understand this vocabulary called amplitude. The amplitude of a periodic function is half the difference between the maximum and minimum values. So if you want to find the amplitude for of these sine graph and cosine graph, you're going to look at the difference between the maximum point and minimum point, and then you're going to divide them by 2. It describes the height of the graph both above and below a horizontal line passing through the middle of the graph. But instead of, for example, for sine of x, for the parent graph, it goes as high as +1 and as low as -1. So the difference between the positive and the maximum and the minimum point is 2, and its half is 1, right? But basically, there's an easier way to find the amplitude. If you just take the absolute value of the beginning number here, you can find the amplitude. No matter what the value of the amplitude is, the period of y equals a sine of x and y equals cosine of x are still 2 pi. Their period will be still 2 pi. Now, if the 2 is not here at the beginning, but if the 2 is before the x, so this means now it's actually, this is called horizontal stretch or compression. So if the 2 is not affecting the y values, but if the 2 is next to x, that's going to change your actually period. So for example, the graph like y equals 4x, it's going to change your period. So I would like to show you something for y equals sine of x. We have our 5 key points that I showed you before. You know that when x is 0, this gives me a 0. When we have pi over 2, it gives me a 1. When I have pi, it gets me back to 0. 3 pi over 2 is -1, and 2 pi is 0 for the sine of x. When I have y equals sine of 4x, now the 4 is not at the beginning of the sine, but it is at the beginning of x, so that's a whole other story. This means I want to still get the same y output, 0, 1, 0, -1, 0, but I have to modify my axis to match this criteria. So now, when x is 0, this is not going to work. I mean, it's still 0 because, but what's going to happen is now I have to divide pi over 2 by 4, if I divide pi over 2 by 4, and dividing pi over 2 by 4 means multiply it by 1/4. So that makes me a pi over 8. Now I have to make my x to be a pi over 8 to get the same y value, because 4 times pi over 8 now gets me pi over 2, and I will basically get sine of pi over 2, which will get me a 1. So when you have a number here in front of the x, all these x values will be divided by 4. So I'm going to also divide pi by 4. I'm going to divide 3 pi over 2 by 4, and dividing by 4 means multiplied by 1/4. So that's 3 pi over 8. And then I'm going to divide 2 pi by 4, which will simplify to pi over 2. So the same y values that we're going to reach. So the same y values we're going to reach, which is 0, 1, 0, -1, 0. It's not going to run from 0 to 2 pi, but they're going to run from 0 to pi over 2. So the distance we are covering will be 4 times narrower than what we have to cover by the original graph. This is the pi over 8. This is pi over 4. And then this is 3 pi over 8. So that's what happens when the number in front of the x changes from 1 to any other number. So y equals sine of x and y equals x. The difference between them is y sine of x, the original graph is going to run from 0 to 2 pi. But when the graph question changes to sine of 2x, the distance you will be covering will run from 0 to pi. So the period will be 2 pi divided by 2, which is just pi. So when you have any number in front of the x, you're just going to divide the 0 to 2 pi, those 5 critical angles, by the b value to get your near endpoints in the graph. So the graph of y equals sine of bx will resemble that of y equals sine of x, but the period will change. Period will no longer be 2 pi. Period will be calculated 2 pi divided by b. Similarly, for cosine of bx, whenever you have a number here different than 1, like 5, 3, 2, it's going to look like the cosine of x graph. The shape is not going to change, but the period will be 2 pi over b. If you look at our next example, we want to look at the graph for y equals 2 over 3x. So the b value is here 2 over 3. We're going to have to calculate our near period. So we're going to divide 2 pi by the b value. In this case, it's 2 over 3. Copy the first one, multiply it by the reciprocal of the other one. So the period is 3 pi. So one full cycle of the cosine curve has to fit in from 0 to 3 pi. And then you can get the new points. And then when you connect them, you will have the graph of cosine of 2 over 3x. So the way I do this without a calculator on my own is, again, I just create the chart for the main graph for, which is cosine of x. And then we said that there are 5 points, 0, pi over 2, pi, 3 pi over 2, and 2 pi. We start with 0, and no, we don't start with 0 for cosine, because cosine of 0 is 1, cosine of 90 is 0, cosine of pi is -1. This is a 0, and this is back to 1, right? But if somebody asks me, now I want you to graph cosine of 2 over 3x, what I do is I say, okay, I will still get the same outputs, 1, 0, -1, 0, 1, but instead of copying the same x values, I have to divide each x value by 2 over 3. So when you divide 0 by 2 over 3, you still get 0. That doesn't change anything. But when you divide pi over 2 by 2 over 3, dividing by 2 over 3 is the same thing as multiplying by 3 over 2. So that gets me at 3 pi over 4. Therefore, on the graph, 3 pi over 4 is going to match with 0. 0 matches with 1. So this is 0, 1. 3 pi over 4 goes to a 0. Next angle is pi, but I'm going to have to divide pi by 2 over 3, which means multiply it by 3 over 2. That gets me 3 pi over 2. And then my next point on the graph needs to be 3 pi over 2 has to go to a -1. And then next one on the graph is 3 pi over 2. I have to divide it by 2 over 3, which means multiply it by 3 over 2. That gets me 9 pi over 4. So 9 pi over 4 will match with a 0. 9 pi over 4 will match with a 0. And then last angle is 2 pi. And we want to divide it by 2 over 3, which means multiply it by 3 over 2. And then the final angle I will need on my need chart is 3 pi. And 3 pi will match with +1. And when we connect these 5 dots, this will be the graph for cosine of 2 over 3x without a calculator. This is how I can obtain the graph. There's a cool guideline here for sketching graphs of sine and cosine, so you will need it when you are doing your homework questions. First step is find the period, and you can find the period dividing 2 pi by the number in front of the x. If it is just 1, you're lucky, so its period will be 2 pi over just 1, if it is 1. But if it is any number then different than 1, you have to divide the 2 pi by b to find your new period. And then you're going to divide the interval into 4 equal parts. And you're going to evaluate the function for each of the 5 x values resulting from step 2. And you're going to find your maximum point and minimum point to calculate your amplitude. And then you're going to graph the points over the period. Last example we're going to look at is how would you graph y equals -2 sine of 3x over the 1 period interval? I think instead of using the book way here, let's see, do we have space here? I can add a page here, and I would like to copy the question here. The question was y equals negative. So here the question is, we're going to finish today's this video by looking at the graph for y equals -2 sine of 3x over 1 period, and the answer we need to get looks like this. And let's try to see how can we get this graph without using a calculator and how I will do this. So I am going to first again sketch my 5 critical points just for y equals sine of x, which is the easiest version of the sine graph. I need an x value and I need a y value. And I always need my same 5 angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to evaluate my sine function for these 5 angles. Sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and sine of 2 pi is 0. And now my new function y equals -2 sine of 3x. Let's discuss what will be affected and how is this going to change. First of all, my y values will not stay the same. All of my y values will be multiplied by -2 because this is called a vertical stretch factor. So first thing is y is not going to stay the same because all of the y values are getting multiplied by -2. So I'm going to go ahead and multiply all of them by -2. 0 times -2 is still a 0. 1 times -2 is -2. 0 times -2 is a 0. -1 times -2 is a +2. And 0 times -2 is 0. This is going to change the y values. However, there's one more thing that I have to think. It's no longer just 1x. It is 3x. So these 5 critical angles, all of them must be divided by 3 because our period is going to change. So I'm going to have to divide 0 by 3. 0 divided by 3 is just a 0. Next, pi over 2 needs to be divided by 3. So pi over 2 needs to be divided by 3, which means I need to multiply it by 1/3. So that's going to give me a pi over 6. And then the pi must be divided by 3. So I have to be multiplied by 1/3. So that's going to get me pi over 3. 3 pi over 2 needs to be divided by 3, which means I need to multiply it by 1/3. So that's going to get me pi over 2. And then 2 pi needs to be divided by 3. So that's going to get me 2 pi over 3. So I have everything I need to sketch the graph. And then because my sketching is not the best, I'm going to show you how the numbers that I got make sense on this given curve. So let's just bring this curve over here. And then let's just make it fit a little bit better. And here, 0 goes to 0. And this is 0, 0. I need to show them pi over 6 matches with -2. This is my pi over 6, and it matches with -2. Pi over 3 is going to match with 0, and this is pi over 3 comma 0. Pi over 2 matches with 2. This is pi over 2, and it goes to the +2. And 2 pi over 3 matches with a 0. And then when I now connect my 5 points that I got using my logic, I will get the full cycle of -2 sine of 3x. This is one period. If they ask you to draw it for 2 periods, you're just going to solve 2 pi over 3. So each period is 2 pi over 3. If you add 2 pi over 3, another 2 pi over 3. So the next curve is going to end at 4 pi over 3. So you will need to extend this all the way to 4 pi over 3. And then you're just going to copy this exact same figure one more time if they wanted 2 periods of the curve. Anyway, but they wanted just one curve. So we're just going to stick with this blue graph. And if somebody asks you what is the amplitude here, so you look at the highest point 2, lowest point -2, and then you look at the difference between these two numbers. The difference is 4, but then you must divide them by 2 to find the amplitude. Amplitude is equal to a 2. Other ways to find the amplitude is you just draw the middle line here. It's 4 units. And then half of the 4 units is amplitude will be the 2 also, again, using the same important information. This is end of 4.1.